So we're gonna do day 2, Cube Conundrum. You launch high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes which are either red, green, or blue. Each time you play this game, you will hide a secret number of cubes in each color in the bag, and your goal is to figure out information about the number of cubes. To get information, once the bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. You do this a few times per game. You play several games and record the information from each game, your puzzle input. Each game is listed with its ID number, like the 11 in game 11, followed by semicolon separated lists of subsets of cubes that were revealed from the bag, like 3 red, 5 green, 4 blue. Okay. For example, the record of a few games might look like this. Yeah, blue, red, green, red, whatever. In game 1, 3 sets of cubes are revealed from the bag, and then put back again. The first set is 3 blue cubes and 4 red cubes, second is 1 red cube, 2, yeah, etc. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. Okay, so I've thought about this already. Like I've just read it, but I've also read the description earlier. And this seems like it would be really difficult to do in assembly. Like it seems basically like part 2 yesterday, but I think it's actually not that bad. Because we can take like a ton of shortcuts. We don't actually need to parse all of this. Because like we don't actually care about this number because it's always just increasing. So you can just count the number of lines. And so you can just skip until we find a colon here in the beginning. And like we don't need to parse blue. We just need to check the first character, and if it's a B, we just skip like what's that, 5 characters, and then if it's an R, we just skip the rest, and so on, right? So it's actually really not that much we need to check. We just need to check that all of those are like less than those. So the red ones are less than 12, the green ones are less than 13, and the blue ones are less than 14. And if we do that, that should actually be like everything we need to do. So I actually don't think it's that difficult. But I guess we'll see. Yeah, so let me just set up my things again. Yeah, I guess I'm just gonna copy like at least the reading functions from yesterday. Okay, so what can we keep? We can keep read chars. We can keep print number because we're gonna need that one again. And wait, did I change anything about that? I guess we should use this one. No, actually we don't need to. We don't need to look at buffer like we did yesterday. Oh, I still have my debugs in here. Yeah, oh well. Yeah, so I guess we just need print. We don't need, or we do need start, but we don't need to do, actually we do need to do this one. And we don't need this part. And we don't need any of this, except for the exit at the end, obviously. And yeah, we need all of that. Okay, cool. So, right, input a text. Get our puzzle input. Okay, and let's start parsing, I guess. Yeah, okay. So, yeah, this initialized our input, and now we can actually start parsing. So what are we gonna do? I guess we have our main loop, and I guess we have like our like line index, I guess. So we'll initialize line index with 1, because lines are 1 indexed, right? Starting at game 1. And then we're gonna we're gonna read until we enter the first colon. Right. Actually, I don't think we need to do it like, yeah, I don't think we need to do it like this. We can just do read char, and if that one is a colon, I don't know what the ASCII code of that one is. Hello. I'm using x86 because that's what I'm on. Oh, and assembler is Nesn, because I don't know, that's what I had. Honestly. Yeah. Okay, so that's 58. So okay, so if we haven't hit a colon yet, we're gonna jump back, and if we do then we are here. Okay. So we skipped the game part, and now we need to pass. We need to check all of those. I guess we need to skip one character and pass one number. We need to write a function for that. And then check the first character and skip until the next comma space. Yeah. Okay. So I guess we discard the space after the fun. And yeah, and now we need to reach a number. And I guess we need to write that one. Okay, so I guess reading a number is actually not that difficult. Because we just read a character, and actually this one reads one past the last digit. It gets that one RAX. Oh, actually, let's move that one to BX. Yeah, let's move that one to BX. Why not? So it reads one character, and now if that one is less than 0, so it's 48. Then we jump to read done because we read one past the last digit. Yeah. And if it is larger than 9, we'll also jump past. Okay. And if it's not, then I guess we need an accumulator. So we move we'll just actually let's use IX here. We'll move 0 into IBX, and if it once we hit a okay, so we have a digit here, so we can subtract 48 from rex to get the digit value, because it's all ASCII, and I guess we just multiply RBX by 10 and add rex, right? So yeah, because like any number n concatenated with I guess how do you concatenated with then digit d is the same as n times 10 plus d, right? So that's what we're doing here, and then, yeah, I guess that's it actually. Then we jump back to our loop, and once we're done, I guess we can, if we return rbx, we just return here. Okay. Maybe not the nicest way to do that with rbx and rx here, but yeah, that's fine. Hello, nice to see you again. Yeah. Okay, right, so we can read one number, and we are currently, okay, so we've skipped the first game part, because we know we don't actually, are you okay with skipping the first knowledge category? Yeah, we are, because there's always a space afterwards. So, and we would have to skip that one anyway. And we don't need to pass this one, because, well, if we did, it would still be fine, because there's always a colon afterwards, but we don't need to pass this one, because it's only, like, increasing. We can just count the lines. That's easier. And yeah, after this one, there's always a space, so that's fine. Yeah, okay. And otherwise, we would need to, like, look ahead. That took me 3 hours yesterday, so let's maybe not do that. Okay, so we have the number in rbx, and I guess we can just wait. Does read char muted rbx? No. Okay. Let's add a comment so we can define on that. We probably have one char input buffer like angeht C. Yeah, probably. That would actually be pretty easy probably to do, but yeah. We don't need it, so I guess, you know. It's all like super hacky anyway. So just read char, and now this is the first digit, or actually, that's bx equals, it's our count, and now our ax is the first digit of our color. It's not always by color. And right, now we just need to, I guess we just need to, like, have one case for each, if we don't even need one case, we can just use, like, cmoves. We just need to check that that's lower than our maximum. I guess that's it. Yeah, okay. So, I guess we can do, we know it's always going to be a valid color. I guess we're just going to assume that. Oh, actually, no, that's fine. We can, yeah, we can just, like, what I was just wondering is, like, how do we know when one group ends? And that's fine, because we just check if that's a, if there's a comma or a new line or a semicolon afterwards. We actually, like, in part 1, we don't actually care about the difference between commas and semicolons. It's like those are different groups, but we just check that they're valid. And so, like, if we have something invalid, like 19 blue here, or if it's 19 blue here, that doesn't make a difference. We don't actually care about that yet. So we can just like treat commas and semicolons identically. So we just need to check if after one color there's a new line. Yeah. Yeah, that's what's kind of fun about Advent of Code is, like, you have all these people doing Advent of Code in, like, Haskell or Okama and using like parser combinators for this. But if you do it in Assembly, you just notice so many, like, shortcuts you can take that you just don't even need to care about. It's kind of fun. Okay, so we have first digit of our color, and so I guess we'll compare that one with 12, which colors we have. Red. Yeah, red is 12. So that's an R. So 114. The splitting on semicolons and then splitting on comma and then splitting splitting on colon and then splitting the RHS and semicolon and then splitting each segment and comma. Yeah, that's probably what I would have done in the Haskell comma as well. And then splitting spaces. Yeah, exactly. That's pretty much what I would have done. It's just so much more work than just, like, at least in assembly, so much more work than just, skipping the commas and stuff. So, yeah. Anyway, okay, so what was I gonna do? So I'm comparing Rex with, if that's an R, that means it's 114. And so I guess we can C move equal into RCX. What's the limit? 12. Okay, so there are 12 red ones. So we're gonna move that one to RCX and actually, let's add a comment. Yeah, 12 red cubes and actually we don't need to know how many characters are in red because we just read until we find either comma or semicolon or a new line, right? Yeah, that works. So now, if we compare that with green, then that's 103. It's red, green, blue, red. Yeah. So in that case, we need to move equal 13. And yeah, I guess we can just assume that everything else is no, we can't because we need to conditional move. So I guess we do, if it's 89, so it's blue, move 14. Let's add a comment there. Actually, I don't know if you can use like ASCII characters like this in NASM. I don't know. Oh, let's not not try that yet. I actually think you can, but I'm just gonna use the numeric codes just to be sure. Okay, so RCX contains the limit right now. So I guess we just subtract, actually just compare what's our number, RBX and RCX, and if it is greater than that, so if our number of cubes we have is larger than the one we are allowed to have, then we jump to invalid game. And otherwise we'll skip until the until the semicolon or new line or comma, I guess. Yeah, so now read until semicolon comma new line, which, okay. So I guess we'll read a character, compare that one with with either semicolon and yeah, if it is equal to that, then yes, it's just separator. That one is a semicolon. Then we'll jump to separator found. We found a semicolon, or if that one is a comma, we'll also jump the separator func because we can treat those identically for now, at least. And if that one is a new line, then we'll jump to new line. Okay. And otherwise we'll just jump back and keep reading. Okay, so that's that loop. If we find a separator, I guess we can just wait. 58. What was that one about? It was colon. Oh, right. Wait, where was our colon? Right, it's that one. Return to colon. Okay, so that's this one. Yeah, so that's our read game thing, I guess. Oh, hello. Hello, Lightcheck. Thanks for the raid. We're doing x86 Agent of Code in x86 assembly, as you can tell. And it's much easier than yesterday, I think. Okay, I spent 4 hours on part 1 and 2 yesterday. That was fun. Yeah. Thanks. But I didn't exactly feel hardcore yesterday, but you know. Okay, so if we find a separator, I guess. Wait, we are at. Okay, if we find a separator, we are here, right? And that's equivalent to if we are here. So we can just jump. We don't actually need this one. We can just jump to our group thingy. Put it together in Python. Oh yeah. And C#. Yes. Yeah, I also have a version in Haskell, or 2 versions in Haskell, and like part 1 is literally a one-liner in Haskell from yesterday. I spent like less than 5 minutes on this one and an hour on this one. So yeah. Yeah, I'm not going to do everyone in assembly because like day 24 or something, that's gonna be fun. Okay, so wait, I think we already have like half the thing, no? Because we can read. If we're gonna read this one, then we're gonna read up. Or we're gonna read a number, space, first character of the color. Then we're gonna compare like if the amount is valid, and then skip until we've hit either comma or semicolon, and then repeat that one until we hit a new line. Yeah. Okay, and if we hit a new line, then actually we need to do invalid game. If we found one that's invalid, we just skip until we find a new line. And like skip this one, I guess. Yeah. So I guess if we found a new line, then that means we this game is valid. And that means we can add to our total count, or what they call it. Let's move the line index to the register, add that to total count, and and jump back to our main loop here. Actually, we don't want to move line index 1, we want to increment our line index. So that we do that on every iteration, obviously. And so I guess we can jump back to our main loop. Right, and if we found an invalid game. Oh, actually, we also need one for 0, for end of file. One thing I did in x86 assembly is like debug my C code when Windows does weird things. Yeah. Well, I've actually like things I've barely used GDB for debugging C code. I've used it like way more to debug assembly than C, but you know. Okay, so if it's in UF, God, what are we gonna do? Then yeah, let's just skip to that one. Oh, actually, that's a slight race condition here. Or not race condition, but a slight issue here. No, there's not. Actually, is there? Like there's a difference if we find an EOF on interfile while we're in a valid game or while we're in an invalid game, but I think that's fine. Yeah, if we're in an invalid game, we don't even hit this one. Right, because it's gonna jump into invalid game earlier already. So that's fine. Yeah, because we need to do that one again. Yeah, I'm not gonna worry about that one in a second. Using debugger for assembly code feels like using a Lisp raffle. Yeah, a bit, yeah, actually, kind of. I haven't actually used many Lisps. I've tried Clojure a little, but not much. And I kind of want to do one of the later ones in Clojure, maybe. And I've used some Racket, but also not that much. It's a nice language, though. Yeah. Okay, but yeah, this one. Wait, this already. Oh no. This is we need to do. No, that's correct. Yeah, I already did that. To learn factor. Oh, that's an interesting one. Okay, that's like fourth or like stack based, like fourth, right? Okay, cool. I guess yeah, in this case we just read a character. This one is either a new line. Then we just jump back to the loop without let's equal. We just jump back to the loop. So we just let me just add a comment for that. Jump to the loop without incrementing total count. What's it? Is it a total score? I forgot what they called it. Total sum. Something like that, yeah. Sure, it's called total sum. Okay, so that's if we found a new line, and if we found an end of file, we're gonna jump to one ELF invalid. And we'll worry about that in a second. And otherwise, we just keep reading and skipping characters. Okay. So that gets us through this one, like to the end, and if it finds an invalid number, it's just gonna skip the current line and continue on the next one. Oh, actually, no, it's oh, I don't think I've done that one correctly. No, I have. Read until colon. That's perfect. Okay, good. Right, so I need to do those, and then that's actually already. That should be everything. First try. Let's see if this actually works at all. So if it's an invalid, if it's a valid ELF, you still need to include the last ID. And otherwise, we're just not going to do that. We can just fall through here. Okay, and so we've found our total sum, so I guess we just move that into Ix, I think, and call number. And I think that's it. Number takes an input in Ix, right? Yeah, actually that should theoretically work already. 155. Yeah. No. Yeah. 101. Incline index. Oh, you can't do that. No, you can. It just needs to do a keyword. 18. Move. Oh, you can't do. Wait, you can't do conditional move with an immediate? Can't do that? What's that? Oh no, that's has a different name, right? God, I need to do that. I think, yeah, if you do conditional move, CMove is only register. Yeah, which one is the with an immediate? Is it C set? No, that's C something. I think there is one, right? What's that one called? Is it set E? Or is it something else? I don't know what that does. Let me just Google that one. Set E is set byte on condition. Set E. It's argument to one of the zero flags set. No, that's not what I'm trying to do. Yeah. Okay, that's not the one. Is there really no immediate, like CMove with an immediate? Is it really not a thing? Huh. I guess I just register then. Oops, that one should be 13. It's better. And I've caused an infinite loop. Okay. Let's start up GDB. Actually, I don't want any of those. I don't want any of those anymore. Okay. And yeah, let's keep my extra. Actually, no, we don't need that one anymore. Okay. So let's, I don't know, break start, I guess. Return on GDB. I mean, what else would you use for GDB? What else would you use for debugging? Assembly in GDB, I guess. Okay, so we could get into this code. For assembly, I'm not sure. For C that works, I know, but I think that's gonna be difficult for assembly. Also, that's like the main point where I'm even doing that is I want to see like registers and want to be able to like print what do I have, like total sum, things like that. Print long total sum, I guess. And I don't think I can do that directly in VS Code, even with C. I think. Might be wrong. Yeah, okay, but I have no idea where this thing is getting stuck. Yeah, it's also, yeah. Guess let's try like a single line. Oh, actually, I think the issue is might just be the threading new line. Oh, wow, yeah, it was. Okay. Well, then I guess let's see if that's correct. This doesn't know how to generate debug info. I think so, yeah. I think it does. Screen, and let's see if that's the correct answer. And it is. Nice. Oh, that was easy. 35 minutes. That's actually, yeah, that's pretty good. Much faster than last time. Right, okay, so let's see. Let me just not break my setup. Okay, good. Okay, let's continue to part 2. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure where the water had stopped, however, he can show you how to get to the water source to check it out for yourself. Just up ahead, as you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that should have been in the bag to make the game possible? Wait, what? So consider the game from earlier. In game 1, the game could have been played with as few as 4 red, 2 green, 6 blue cubes. Oh! If any color had even one fewer cubes, the game would have been impossible. Also, it's just the maximum for each number, right? Have the maximum of the maximum that appears before blue, the maximum that appears before red, and the maximum that appears before green. Wait, that's easy? That's so much easier than day 1. What? Game 2 question and played at least 20 reds, etc, etc. Okay. Power of a set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. The power of the minimum set of cubes in game 1 is 48, in games 2 to 15 it was 12. Adding up these 5 powers produces the sum. Okay, so we just find the maximum per color, add those, multiply those together, and add them for every line, and then we get the result. Wait, that's almost easier than part 1, I think. Wow, okay. Gonna be a short stream today, I guess. Nice. Let me just move things back. Okay. Good. Okay, so part 2. Also, I completely forgot to play any music. Let's go on. Okay, good. So, Sheffield easier than this. Yeah, way easier, right? I spent 4 hours on that stupid look at matching thing yesterday. Okay, right. So what do we need to change? I guess we don't jump out into an invalid game. We don't actually need that one at all. And instead, we still pass everything the same way. And then instead of jumping to an invalid game, we don't actually compare to anything, but we just, we have a maximum red. Hello. We have a maximum red with a maximum blue and a maximum green. I guess we just conditionally move into those if we've exceeded that one, and then at the end we just multiply those together, add them to our result, and that should be everything. Oh, that's so much easier. And we don't actually care about the line index anymore. Yeah. Okay, so right, instead of we might actually get both in the first try this time. That would be pretty impressive. So I guess we conditionally move I guess we move into RDX or RCX or wait, no, what are we gonna do here? So we're gonna compare our AX and actually no, we're gonna move our red maximum, what should we call it, max red, into RCX, then we're gonna compare that one to IX, and if we exceeded that one, we'll conditionally move our new IX into CX and then move that one back into max red. Yeah. So max red is the maximum of whatever was in there before and IX. Yeah, that should be everything. And then we do the same for actually no. Only if guess we need separate branches here. We can just do conditional moves anymore because we need to care about the digit the letter as well. So I guess if it's we compare IX with actually don't wait, what's our BX here, not our AX, that's why. Our BX is our number and our AX is our character from our color. Could use CMove to determine the array element you're comparing to. Oh, you could. Wait, so... Yeah, but then you don't know which one to write into at the end, right? Like max red, max green, or max blue, rather than random comparison per color. Right? Because if you mean like C moving the color we are comparing with into a register, and then only comparing with that register, then we still need to know which like field to write back into. I guess we could just use registers for, you know what? We could just use register for our maximum. That makes things so much easier. The index and the array. Yeah, I mean that one would need to be an array for that, but yeah, I guess. But I think if we just use registers for maximum, that's way easier. Let's use R10 max red, 11 max green, and R12 max blue. Okay, and now but that doesn't actually buy us anything, does it? RCX, I guess we can skip something here. Yeah, but I think I just did the range. I think that's easier. You just smooth so you compare with RBX with R10 if it's, wait, that's not green, that's blue. That's red. If we red, we compare our new number with R10, and if it's larger, we'll move it into R10. And yeah, that's it actually. And then jump to, I don't know, something. And back to where did that one jump? Reach until the separator on your line, okay. Reach until the separator on your line. And I guess we'll just do the same one for green. Right with R11. And with blue. And we don't actually need to jump there. And then we'll just move those comparisons up here, and I forgot what R is, obviously. Yeah, can type 114, right. If it's an R, then we jump it to red, and if it's green, 103, then you jump into green, and same for blue. '98. Okay, so those are our branches. We can just skip that one. Yeah, that's okay. And right away here. And instead of jumping into an invalid game or anything, actually that's it. We just continue on. And then at the end, once we find a new line, we don't move something to the line index, but we multiply R10 with R11. Wait, set it at 10, right? Yeah. And then multiply that with R12. Red times green. It's blue, so that's our cube. And then we just add that one to our total. And that's it, I think. Yeah, it should be it. Right, and we also need to do that on end of fire. And yeah, that's it. And then we don't need this inverted case anymore. Actually, we just don't need the label. We still need the this intense. Hey, you should have been there yesterday. yesterday was so difficult. Like, that whole, like, parsing the words thingy. I don't normally use Haskell, yeah. And, like, yesterday was a one-liner in Haskell. Well, like a bit more than one-liner for part 2, but still, it's just so easy. And assembly took me 3 hours and 389 lines of assembly. And today, like, I've already completed part 1 and part 2 should be pretty much done now. Yeah, this one isn't possible anymore. I'm still in part 1. 101. Right, we don't have any line index we need to care about anymore. Oh, that needs to be IM, alright. Yeah, and oh yeah, someone there. And that's 0. Okay. Well, that might not quite be correct. What could be the issue? So my print function doesn't actually print anything that's 0, because yeah, I haven't written that part. What's happening? Okay, let's GDB. Oh, I need to reset the colors also. So on loop start, I need to move 10 0, move I11 0. Actually, I shouldn't use those. I just realized because I11 is not callie saved, I think. Yeah, something like that. Yeah, let's use. Wait, can I use 12, 13, 15, 13, 14? I think I can, yeah. Let's use 12, 13, 14, because those are safe, I think. Okay, so that's 12, that's 13, that one's 14. And then, yeah, that one's 12, 13, 14. 12, 12, 12. 13, 14, 12. Yeah. Okay. So that one, that shouldn't have fixed anything, probably. Actually, it might have. No, it didn't. Okay. Right, so let's break on loop. Yes. And that's another step through. And yeah, let's step through until we hit one of those, I guess. So reading until we find a colon. Yeah, we found the colon. Like that's day 1. We found, so we are here. We'll read a number. Right. That's 1. That's correct. Yeah, I mean, it was correct last time, so kind of has to be. And now that one is green, so it shouldn't jump into red, but it should jump into green. Correct. And now RBX is 1, R13 is 0. So it's, oh whoops, I'm using the wrong comparisons. That's why. Yeah, this should be C of G, not C of L. Whoops. It's if the new number we've passed is larger than our current one that we incremented. And that gives us our result, and if this one is if this one works, that's kind of incredible. Okay, so let's try it. And that's it. Wow, that was a short stream today. Nice. Yeah, but it was fun. Way easier than yesterday. Like, so much easier. Jesus Christ, it took 50 minutes. Yesterday I needed like 4.5 hours. Yeah, okay, perfect. Yeah. So I guess, short stream today, I find someone to rate, and I'll see you next time.